So without further ado, I would like to hand over and present the next speaker, Nathan Silnitsky, who is a software engineer, I suppose, with Wix still. And he's going to talk to us about workflow engines and event streaming brokers and how those two things go together. Nathan, take it away.
Thank you so much, Gunnar. It's really an honor to be introduced by you. And so, welcome everyone. Before we dive in, I would like to ask you a question. Would you implement a complex business flow, you know, the one has a lot of different actions, a series of actions spun around a lot of microservices? Would you implement that with Kafka and event-driven architecture? I guess some of you in the crowd are on Team Kafka or maybe Pulsar, maybe do it with Kafka streams, while others will prefer more orchestrated fashion, imperative style coding, maybe. So Saga choreography, Saga orchestration, solutions like that. If you asked me 6 months ago, I would definitely tell you 100% let's go with Kafka. But since then, I have learned a lot about workflow engines like Temporal. And today my answer will be a bit more nuanced and with trade-offs, and we'll see why later on. So I'm Nathan Silnitsky, and I'm a backend infrastructure tech lead at Wix. And for the last 4.5 years, I've developed messaging and event streaming infrastructure on top of Kafka for Wix's microservices. And other than that, I'm a big yoga enthusiast, and I also given many talks in many different conferences and wrote a lot of blog posts on Kafka and event-driven architecture. So a few words about Wix. Wix is a powerful website building platform. We're the pioneers of using AI to help with generating websites already back in 2016. And with the Wix platform, you can manage your online presence, but also manage your business online. So from managing your schedule and bookings for your yoga Pilates studio to sophisticated tools like third-party dropshipping. Now, our goal is to allow any type of business, big or small, to use the power of the Wix platform. And for that, we have quite a big and complex distributed production environment with a lot of different business verticals, e-commerce, restaurants, bookings, hotels, and stuff like that. So it really means that we need to be very vigilant about the technologies we use and allow them to offer us a lot of flexibility and power, especially very high scale. So here you can see a few numbers. So for instance, we have around 3.5 billion daily HTTP business transactions and incoming to our cloud, and around 70 billion Kafka messages that we process every day. And that's done with 3,000 microservices in our production system. And they are implemented mostly with event-driven architecture style. And that allows us to have better scaling, handling, and a lot more resilient distributed system. And that's based on Kafka, of course. So we do enjoy it a lot, but we have a few limitations with that system that I'm going to talk about. So with Kafka and event-driven architecture, it's really working great for us. We have very high-speed event streaming with Kafka. And in terms of messaging pub/sub patterns, we created our infrastructure on top of Kafka that we call Greyhound, allows us to do all kinds of consumer retry strategies and better performance with parallel processing, batch processing, and stuff like that. And we also really like that Kafka gives us, for 3,000 microservices, a great deal level of decoupling and the ability to have easy extensibility. You just spin up more consumers for more use cases, and that's really important for us, as we want to have an open platform that is not only for internal developers but also for external developers on top of the Wix platform. And finally, we also really enjoy this event streaming from our databases that allows us to easily create materialized views on top of data that is for each and every service in order to optimize our query performance. So a lot of great stuff that we enjoy from Kafka, but we do see a few minor gaps. One of them is in the area of the question I asked you at the beginning about complex business flows. So in this regard, we have the code, the event handler code, spread around all the microservices, and it's quite fragmented, so it's hard to have code comprehension. But what's going on with this business transaction? And also, changing sequence inside this flow is going to be more tricky, and you need to touch a lot of areas. And also, the most important thing is production monitoring. So how we easily find the source of issues, what's going on with incidents in productions, with all these events running around. And the other point is long-running tasks. So here, sometimes we have use cases where the job takes a long time, maybe even several minutes, and in that case, Kafka doesn't have like the optimal support for that. So we'll see why later on. So all in all, we're pleased with Kafka, but these gaps are important because at the end of the day, we want to have the best development velocity possible, to be as fast as possible, to be better than faster than our competitors, and to allow external developers to develop fast on the Wix platform. So we want to achieve the development velocity no matter which area we found the issues, kind of like with Usain Bolt here, one of the fastest runners of all time. So the main story here is how do you compare Kafka event streaming brokers to Temporal workflow engine in the sense of how they compete in microservices coordination strategy. Which use cases are better to be run with Temporal and which are better to be run with Kafka. And maybe they are not really competing against each other. Maybe they can actually run for the same team and work together. We'll see. So by this point, you're probably wondering, what is this Temporal workflow engine I'm talking about? So the basic idea is that Temporal offers a platform for having durable, stateful, complex business flow support. So it really simplifies complex orchestration. And it also offers tools to easily add fault tolerance and resilience to the distributed system where the microservices are running. And it also tries to abstract away all of the different distributed system concerns. It provides a lot of language SDKs in a lot of different languages. So it really allows developers to focus on the business logic and really boost the productivity. So I want to first really make the motivation crystal clear here. So we'll do the comparison between the two with the complex business flow requirements. Then, once we get the motivation clear, we'll do the Temporal overview. We'll get all the features and capabilities it offers. Then we'll pivot and look at the long-running task use case and see why Temporal is better for that than Kafka. And finally, we are considering employing Temporal of Wix, but there is a challenge here to how to integrate it when we need all that level of decoupling and flexibility in our open platform. And we'll talk about that as well. So during my long tenure at Wix, I've been witness to a lot of different business processes, complex business flows from all our verticals. And as we got more and more into event-driven style architecture, the pains started to be a little bit more clear, especially around production monitoring. So let's take, for example, the e-commerce solution. It's easy to follow. So Wix, of course, has one, and we'll talk about the checkout flow. So we have the cart service. It manages the different items in the cart. Then it starts out the checkout flow, and it will interact with the order service that manages orders. We'll first create an order. Then we'll do interaction with the inventory service that manages product inventory, and we'll reserve the inventory. And finally, we'll do payment processing with the payment service. Now, this is a distributed system, and of course there are failures possible here. Or, you know, like you want to get payment across, but sometimes just something happens that you just can't do that. So with sagas, of course, in a distributed transaction, you want to do a compensation. So here we're going to need to cancel the reservation that we reserved before in case of failure, and then cancel the order. And now we're good, and we have our complete distributed transaction. So let's see how we implement some of that with Kafka and later on with Temporal. So how would you do this with Kafka events? Basically, you'll have each microservice in turn consume the previous event, process it, and produce the following event. So checkout started, it was instigated, order service processes it, creates the order, emits the event, and so on and so forth. And in terms of compensation in case of failure, we'll basically get this process in reverse. So payment service fails, emits the event, inventory service listens it, consumes it, will process it, and emit a reservation canceled event, and so on. So this is basically like a saga choreography in a nutshell. But there is quite a sense here that it's hard to grasp and maintain, especially if you look at the code. So now we have these distributed transaction event handlers spread around the microservices, and you get these listeners and processes, okay. And only once you get a view of all of the different event handlers from all the microservices, you start to get a sense of how exactly this workflow works in big picture, high level way, right? And so what if we want to change the order? What if we want the inventory reservation to happen only after the payment was processed? So we're going to need to touch a lot of different event handlers. Now, in terms of understanding what's going on in production, there are tools out there that can help us. We also saw in the keynote Confluent stream lineage product, and it's really nice. You can see the different connections between the topics and the services, and you can see throughput information, or even start seeing like the message stream if you want to, right? But you won't get here the real deep knowledge on the high-level logic of the business flow. And if you have errors that you need to investigate, like some specific workflow, some specific flow failed, right? So this is not going to help you probably. Maybe in the future it will. Now, if we compare this situation to temporal workflow engines, so here we see a pseudocode of the checkout workflow. And you can see it's imperative style, orchestration style. You get the different parts running and basic conditions here. And at a glance, you can already understand basically what's going on in this checkout flow. Behind the scenes, Temporal is going to run the different parts in the different microservices, but that's abstracted away from you. So we have the power and clarity of imperative style single method, and behind the scenes, it's a complete distributed system. And also, you get out of the box this really nice user interface where you get the event history of all the activities or all the parts of the workflow that has been run. And if something failed at some point, you can drill down and say, see exactly what happened and investigate. So a better, more intuitive way to investigate workflow issues. So to summarize here, before we dive into how Temporal actually works, you can see that for complex business flow or distributed transactions, Temporal usually will beat Kafka because it's easier to see the big picture. It's not like the code, high-level code is fragmented around a lot of different services. and change the sequence. Like I mentioned, it will be easier in such a case with a workflow. And like we saw with the production monitoring debugging, out-of-the-box tools are better with Temporal. Of course, you can build all kinds of auxiliary tools to help you with Kafka, but it won't be out of the box. Now, there are situations where Kafka will still be the choice here, especially if you need very low latency, extremely high throughput cases, because the temporal state management of the workflow does have its overhead, much more so than with Kafka. And also with the coupled flexible use case, we'll see later on why you probably want to go with Kafka as well. Okay, so I hope I got the motivation to why workflows like Temporal are interesting. So now let's do the deep dive on Temporal features. Basically, the logical definition here is we have a workflow definition, and it is comprised of a set of activities. So workflow is bigger than activities. It comprises them. And we have the cart service that has the checkout workflow implementation and the activity implementation. Well, there could be activities in other services as well, like order server implements the order creation activity. So if you use the Java SDK of Temporal, all you have to do is specify the interfaces for your workflows and activities and annotate with workflow method or activity method, and you're all set. And here, when you do the checkout workflow implementation, you create the activity instance from the Temporal workflow SDK. You have access to it, and now you can define your method that defines the workflow and call the various activities. And it's omitted here for brevity, but you can imagine all the other activities here as well. Now, this code is actually executed on the SDK workers. So we have dedicated workers for workflows and for activities. And they are coordinated, the tasks between them are coordinated by the Temporal server. So the execution is not done on Temporal server, it's done on the microservices themselves. It just coordinates the work. And other than that, it also has a great deal of sharding, so it easily horizontally scales when you need more and more workflows. And also, it provides a failover mechanism. Let's say the Temporal cluster is down. You can automatically failover to a different Temporal cluster in another region, and so you have very high availability in that regard. Because all the data of which activities and workflows are running is already replicated to the failover cluster. And these workers will actually be getting tasks from dedicated task queues. So we have dedicated task queues for the workflows and activities run by the Temporal server. So here we can see an example with the Java SDK, how we spin up workers, we create new workers. They get the dedicated task queue that you connected to specific workflows. And then you only left to do is register the workflows and activities that you run on the specific workers. So workers can run multiple workflows, and also workflow can be run on multiple workers. And I mentioned the resiliency aspect. So with Temporal, you can have retry built in, where Temporal will take care of, let's say, a pod goes down, where it was running a workflow, that doesn't matter, or activity. When it goes back up, Temporal will make sure that execution will begin from the last place, the first place that it needs to. And let's see how that is defined. Basically, we get the activity options here in the SDK, and you define how long you allow the activity to run. In this case, it will be timeout if it's running more than 10 seconds. Of course, you can have it longer. And then you just specify exponential backoff, where you specify the initial interval, 1 second, up to 100 seconds interval, and up to 3 retries. And so that's pretty much how it works. At Wix, we also have a very similar mechanism for our Kafka-based Greyhound infrastructure. We allow these kinds of retries and others as well, so we do have feature parity in our case. And also with Temporal, a key aspect is that you can run your code that you implement for the business flows in a lot of different popular languages. So we mentioned Java JVM, and we also can run the cart service in Node.js, and it will interact with activities that are actually implemented in Python in the order server or something like that. And by the way, for Wix, with our event-driven architecture, we started off with libraries for the JVM, but then we also needed to start having other languages support for our microservices. So we did a proxy service, and we have libraries dedicated for consumer retries and stuff like that for JavaScript, TypeScript, and Python as well. Now, in terms of debugging, like I mentioned before, we have you can search for a specific workflow that you're interested in, investigate, and then you can easily see what happened. Now, how come Temporal has this really cool UI with everything that happened in the workflow? Well, Temporal actually is the orchestrator. It's stateful, and it keeps all of this information in the database in order to be able to recover and restart where it needs to. So it can easily provide that in a user interface as well. And you can drill down to the activity that failed and look at the root cause analysis. Maybe the stack trace will give us a hint as to what actually happened and this workflow failed. So we saw a lot of interesting features, but Temporal does have a few disadvantages. It may seem like, okay, I can write whatever code I want, and Temporal deals with everything about distributed work behind the scenes, but the workflow code has to be deterministic, and I'll explain why in the next slide. And also, the activities that you're calling, the input and output, must be serializable. So it's not just any random code that you're running here. It's a bit more constrained than that. And also, there is no real support for very low latency use cases if you really want to get the full benefits of everything a workflow can give you, right? Because of this overhead of the stateful management. So what do I mean about like the code has to be deterministic? Well, basically, if we look at the checkout workflow implementation here, we see that we summarize the cart, we call activity, create order, reserve inventory. We're basically mostly calling activities, and there's not a lot of other code here like accessing system time or generating a random number. Why isn't there non-deterministic code here? Well, Temporal needs to be able to replay events in case some worker went down. It needs to be guaranteed to replay events up to the point where it left off and make sure that the result will be deterministic and reproducible. So that's why it cannot have this non-deterministic code found in the workflow. But of course, if you need to have non-deterministic code, you can have it in the activities themselves, generate a random number in some order activity, and encapsulate it there. There's no problem with that. Now, all the red marks here where you provide parameters to the methods, activity, and the values that they return, they have to be serializable. In one of my experiments, I passed an exception. I needed to process an exception. I passed it to the activity, and then in runtime, Temporal failed because I didn't specify that Java exception in the serializers or deserializers that I put to Temporal. So, of course, this serialization has to happen because Temporal server is the orchestrator. It goes and does this over the wire with gRPC. So you have to specify serializable and has to be for all the parameters that you pass. Cool. So now let's look at pivot to long-running tasks. And this use case for me is also important in terms of Kafka support and or lack thereof, and how Temporal does support it better. So from time to time, my infrastructure team at Wix gets questions in Slack like, I set up a Kafka consumer And I wanted it to process only one message at a time, but somehow there were two messages, there was the same message processing twice. And the second processing started 5 minutes after the first one. So 5 minutes, you may know the answer here, that usually it means that the default time allowed before you poll the next message in Kafka. Otherwise, the broker will think that the consumer is down, and you have to, the partition will be assigned to another consumer, and this one will be a zombie consumer from now on. So, for instance, at Wix we have like the payment service, and it needs to do the use case of subscription renewal, and that can take time. So it's subscribed to a specific partition, and processing can take time. Payment providers, banks, or stuff like that, and it takes several minutes. And then we want to process one at a time. We haven't polled for the next message. And we got the message poll timeout, and Kafka decided to give our partition to a different Greyhound consumer. And we're still running the first one, so now we're running two processes of the same message at the same time. But even if you do decide to poll messages continuously, and that's what Greyhound usually does, our Kafka infrastructure, with Kafka there is still the point where you don't want to have too long-running processes taking too much time, even 30 seconds or 1 minute, maybe even too much. Why is that? Because our partition rebalances in Kafka. You want to make sure that our partition, you probably want to get the partition revoked from you only when you finish processing the message. And if that takes a long time, you actually getting the partition rebalance protocol stuck and waiting for you to allow the partition to get revoked, and then you're lowering the throughput here, right? So then the Wix developer either needs to try to break down the processing to smaller chunks, or to allow to increase the partition revocation time, and then you can maybe suffer reduced throughput, or just allow duplicate processing and have the idempotency in place. But anyway, there are trade-offs here, and a lot of mental overhead that the developers need to think about. It's not that easy to abstract away all these things. Sometimes you will hit this issue. I know that Wix developers do hit this from time to time. Now, if we compare this to Temporal, Temporal was built to run very long-running tasks, even with human intervention in the middle, hours, days, how long it takes. And all you need to do is set up a heartbeat to make sure that Temporal knows that you are currently busy, and as long as you do that, it will allow you to run for days on end if you want to. So all you need to do is get the execution context from the SDK, call the heartbeat from time to time, and you're set. No worries, no overhead, mental overhead here. Okay, interesting. So Temporal does give us a few really cool stuff that we can utilize. Now, in terms of how to use the Wix, well, it's not that trivial, because we're talking about Saga orchestration principles here. And with Wix open platform, we need to have decoupling and flexibility as much as possible in our open platform for developers on top of the Wix platform. So if you look at an illustration, what do I mean by an open platform? Well, we have our Wix services, like Wix order service, Wix inventory service. And of course, it provides APIs for Wix developers, usually based on gRPC, inside of our distributed environment. But of course, we also expose them automatically now these days as HTTP endpoints for external third-party developers. For instance, here, they can do their own e-commerce checkout app if they want to. And we allow to have a lot of different plugins by these third-party developers to change the behavior. For instance, Wix order service can call SPI and have a different tax calculation done by the third parties. So that's another level of flexibility. And of course, we have to have a level of decoupling as well. So we emit Kafka events, here order created event, and then internally at Wix it's consumed with a Kafka consumer, but externally it's automatically translated to an HTTP webhook, for third-party apps. Not only that, it is automatically translated to Java callback, to JavaScript callback for custom code that you write in your specific Wix site where you want to interact with these events as well. So very sophisticated open platform. And then we have the question, can Temporal fit nicely into this thing? More specifically, can Temporal actually do pub/sub messaging? Well, there is the ability with Temporal to send out signals to running workflows. These signals have to be done on a specific workflow execution, running workflow execution. So it's more explicit than the way you do it with Kafka. You just produce an event, you don't care if anyone even going to consume it. And it's not designed for high throughput in cases where you need to keep signaling the same workflow execution. And it also has a pretty small limit to the amount of distributed work that you can do for the same the same specific workflow execution. So here you can see how you specify a signal in Temporal. You call checkout started. You define it for checkout started to start that off. And then, like you can see here, you explicitly call it on a single workflow execution here, workflow1.checkout started. So it's a lot more explicit, and I wouldn't say call this pub/sub patterns, right? It's more of a different thing. So what we are left with Temporal is coupled orchestration. We don't have event streaming or event publish subscribe pattern. So if I want to extend the code here and say, okay, I reserve the inventory, I want to make sure that eventually a webhook will announce that inventory was reserved. So I'm going to need to explicitly call like emit HTTP webhook now. It's a lot less decoupled. I mean, you can publish Kafka events in the middle of the workflow, but it's better to do that on the edges of the workflow. Otherwise, you're going to segment the workflow into smaller chunks, and you lose a lot of what a workflow will give you when it's one long workflow, both for code comprehension and production maintainability. So where is Wix thinking of utilizing Temporal? The easier low-hanging fruit here is for long-running tasks, or also for scheduled tasks. You can actually schedule Temporal distributed work on a cron schedule, so the work can be on multiple microservices, doesn't matter. As long as on the workflow options, you set the cron schedule. I want to run this once an hour, once a day, whatever, and Temporal will make sure to execute it for you. But the main point here is about handling complex business flows. So what can Wix do here? Well, maybe we can just use a workflow, but inside the boundary of a single microservice. Or alternatively, because we lose some of the benefits of temporal workflows if we do that, maybe we can do it with dual use, where you get the Kafka triggered or HTTP triggered flows with the open platform. Plus, in addition, you can also trigger the same flow with Temporal. So what do I mean by these two options? The first option is we get the workflow done only inside a single service. So we keep the decoupling going because we get incoming HTTP, we have Kafka in the middle of the services. But like I mentioned, you're going to lose a lot of the workflow benefits because you get smaller workflow chunks. So you start ending up with the same dilemma of how to monitor in production, how to see the high-level flow. Because usually these flows are on multiple microservices these days, right? Now, the second option is to have it both ways, to also trigger it by Kafka or HTTP, and also with Temporal. But we have two paradigms here. We have basically a more choreography type event based and orchestration with Temporal. So we need to make sure that both can work behind the scenes together. And you will also want to reduce the complexity from developers as much as possible in order to avoid the limiting development velocity, right? You basically want to have, okay, we have what we have today with the open platform, and you just add some annotation and you also get Temporal out of the box or something like that. So that was about Wix, but in general, what would you want to do for your microservice coordination strategy? Well, I would say that definitely go with Kafka if you have very low latency situation requirement, and especially if you have a lot of customized decoupled logic that you need to be extensible and change and allow to change and be pluggable. On the other hand, I would go with Temporal if in case your flows include long-running sections in them. In that case, you may prefer to go with Temporal. And also, if your business process is standalone, you're not worrying like Wix is worrying about having the extensibility built in without an issue. You have your 4 microservices at a time, and you want to build the workflow on top of that, and that's it. So to summarize, for Wix plans, Wix has a rich and diverse distributed system and open platform mindset. And Kafka and Wix infrastructure, that I mentioned Greyhound, allows us to have flexibility, extensibility, resiliency built into the system. But Wix is considering to inject Temporal in strategic places in order to increase development velocity in those areas that I talked about, these business verticals that need to run those complex business flows. So I hope that today I gave you a few things to consider. I know some companies that just don't, for their business transactions and the microservices, they don't use events, they work with workflows exclusively. I know with Wix and a lot of other companies have Kafka as the backbone. And can they both work together? Well, we at Wix are excited to try out, and hopefully there is a lot more to come, so we'll see about that. And if you're interested to learn more about Greyhound, you can check out it on GitHub. And there, I put one of my talks here about lessons that we learned from running event-driven microservices. It used to be 2,000 back then, now it's 3,000. And I put all the links and slides on SlideShare that you can easily access them there with my name. And one final note is I have all my previous talks on Kafka and event-driven architecture on my website, natansil.com, and you can follow me on Twitter and LinkedIn for updates in that area, what we do at Wix. And that's it. I would really want to thank you now.